this YouTube channel. I'm Mr. Kibor, a senior mathematics teacher at Lelbach Boys High School. I teach mathematics and business, but I major on mathematics because I've come to realize that mathematics is one of the subjects that is a great pillar to the career progression of any student. Yet most of the students take the subject as a difficult subject, but I'm here to give you some good news that mathematics is actually one of the easiest subjects that any student can do very well. Any student can count it as a booster subject, and I've done this for many years, working on the attitude of the students, working on the best delivery methods of teaching mathematics, and I have endeavored to reach so many students across the country and even beyond through this YouTube channel. I can assure you that if you continue subscribing, watching and following this YouTube channel, we can learn a lot. We can change the attitude of students towards this subject, mathematics, as I believe that mathematics is very easy, and so I will make sure, I will see to it that you also agree that this subject is easy. So what you need to do is that every now and then I post a certain topic, I post a certain any content that I will do in this channel. Please subscribe, watch and even comment, and I'm very sure at the end of the time we will be able to learn together. Thank you so much. Welcome to this YouTube channel. Today we are going to look at the question on a certain question on equations of a straight line. Our today's question, as you can see, reads that a line L1 passes through the points -2, 3 and the -1, 6, and the perpendicular to line L2 at point -1, 6. The first part of our question, question A, reads that find the equation of L1. As you know, whenever we are asked the question to find an equation of a line, it's either we have been given two known points where the line passes through, or you have been given one of the points and the gradient. In this case, our line L1, we have been given the 2 points where the line passes through. This will help us to find out the gradient. Now, in this question, we have been given the line L1 passes through -2, 3, and the same line passes through another known point -1, 6. These 2 points here will help us find out the gradient. As you know, the gradient of a line is equivalent to change that happens on the y-axis of a change that happens on the x-axis. Now, let us take this one to be our first point, x1, y1. We take this one to be our point, x2, y2. And so, the change that will happen on the y-axis, we take this one to be our reference point. It will be 6 minus 6 is the coordinate of y minus the coordinate of y on this side 3 over the coordinate of 6. We say this is our reference point, so we take -1 minus 2. This will give us 3 over 1. That tells us our gradient is 3. So we already have the gradient of the line. From there, now we try and find out the equation of the line. The equation of the line, we will have to introduce another unknown point where this line passes through, that is x, y. And then we follow the same procedure. We now use the known point, one of the known points, with the unknown point to find the gradient. So using the unknown point as the reference, we have y minus, let us use a point like this one, we use this one, you can use either one of this, but let us use this one. So it will be y, the unknown point, minus 3 over x minus 2 should give us the gradient. Now, after this we will have y minus 3 over x plus 2 equivalent to 3. Taking this to this other side, we will have y minus 3 equivalent to 3 into x plus 2. Opening this bracket, we will have y minus 3 equals to 3x plus 6. Now, taking that 3 to the other side, we will have y equals to 3x plus 9. This is our equation of line 1. We proceed to question part B. The question part B says that find the equation of L2 in the form of ax plus by plus c equals to 0, where a, b, and c are constants. Now, in this case, we have been told that line 2, in the first question we have been told, in the first statement we have been told that line 2 is perpendicular to line 1, and it passes through, and it's perpendicular to line 1 at point -1, 6. As you know, for perpendicular lines, let's say L1 and L2. If the gradient of L1 is M1 and the gradient of L2 is M2, then the product of M1, which is the gradient of L1, multiplied by the gradient of L2, which is M2, should give us -1. Now, in this case, the gradient of L1 is 3, M1 is 3, multiplied by M2 should give us -1. Over 3, you find that our M2 is -1/3. -1/3 now is the gradient of L2, which is actually perpendicular to L1 at point -1, 6. And so, the equation of L2, we will have to, L2 passes through the point -1, 6, and we have another point, unknown point xy, the gradient equals to -1/3. So the equation of this line will be y minus 6, the known point, over x minus -1, which becomes x plus 1, equals to -1/3. Cross multiplying this, we will have the following. We will have 3 into y minus 6 equals to -1 into x plus 1. This we will have 3y minus 18 equals to -x minus 1. Bringing -x to this other side and -1 to this other side, we will have x plus 3y minus 17 equals to 0. Now, this equation of line 2 is in the form ax plus by plus c equals to 0. In this case, the coefficient a that is applied to x here is 1. The value of coefficient of b is 3, and the plus c in this case is 17. That is all about question 2. Let's move on to the question part C. Question part C says that given that another line L3 is parallel to L1 and passes through the point 1, 2, find the x and y intercepts of line L3. Now in this case, we know that parallel lines share the same gradient, and so the gradient of line L1 and is equivalent to gradient of line L3, which is the same as the gradient of L1 was 3, and so the gradient of line L3 is also 3. In this case, the line L3 passes through the point 1, 2. We will have a known point x, y, and we have the gradient as 3. In that case, finding the equation of the line L3, we use the unknown point y minus 2 over x minus 1 equals to 3. What shall we have? We will have y minus 2 equals to 3 into x minus 1. Y equivalent to y minus 2 equivalent to 3x minus 3. In this case, we will have y equivalent to, taking that negative 2 to the other side, we will have 3x minus 1 because 2 will be positive upon reaching the other side. Now, we have been asked, this is the equation of L3. We have been asked about the x and the y intercepts of L3. Now, at y-intercept, x is equivalent to 0. The coordinate of x is equal to 0. You must know that y-intercept is the point where the line cuts across y-axis, and at that point, all the coordinates of x on the y-axis is 0, and so we will take the equation y is equivalent to 3x into 0 minus 1, which becomes y equivalent to negative 1, and so the y-intercept is negative 1. X at x-intercept, y equals to 0. At x-intercept, y equals to 0. And so we will take the value of y here, we put 0, then we equate to 3x minus 1. Taking that negative 1 to the other side, we will have 3x equals to 1 over 3 over 3, x equals to 1 over 3. And so the x-intercept equivalent to 1 over 3. The last question, we move on to question number C. D. The question number C says that find the point of intersection of line 2 and line 3. Now, the equation of line 2 is x plus 3y minus 17 equals to 0. Writing this in the form of y equals to mx plus c. Then we will have to take x and negative 17 to the other side. X was positive, upon reaching the other side it would be negative. This 17 was negative, it would be positive on the other side. So we will have 3y equals to negative x
plus 17. Now, we want to remain with y alone, so we will divide this side by 3, and so we will remain with y equals to negative 1 over 3x plus 17 over 3. This is our line 2. The equation of line 3 was y equals to 3x minus 1. Y equals to 3x minus 1. This is our equation of L3. Now, we have been told to find the point of intersection. Let's say this is our line L2 and this is our line L3. And so, at the point of intersection, the two lines share coordinates x, y. They share coordinates x, y. And if they share coordinates x, y, remember x, y and x, if each and every line represents the unknown point where those lines pass through. And so one of the points both lines pass through is their point of intersection where they share. And at the point of intersection now we have realized that both lines share coordinates x and y. And for that case, it means at the point of intersection, this line L2 and line L3 will share coordinates y, and y will be the same, x and x will be the same. And if so, then this y and this y will be the same. That means also whatever is on the other side of the equal sign will be the same. And so we will have negative 1 over 3x plus 17 over 3 equivalent. This side of the line 2 will be the same as the other side of the line L3, 3x minus 1. I want to remove the denominator 3 here, so I'll multiply this side by 3, I multiply this side by 3. This 3 and this 3 goes, we will make it negative x plus 17 equivalent to 9x minus 3. Now, taking this negative x to the other side becomes positive. It becomes positive 9x plus x then x. Taking this negative 3 side to the other side becomes positive 17 plus 2, which is 3 over 10 over 10. And so we have x equivalent to 2. So at the point of intersection, the value of x is 2. Now let's find out the value of y. Y will be the same as 3x minus 1, but we already know x, so we will have y equivalent to 3 into, in place of x we place 2 minus 1, and so we will have 3 times 2, 6 minus 1, which gives us 5, and so y equivalent to 5. So the coordinate x, y for this case will be the same as 2, 5. Until next time we meet again, please don't forget to subscribe